We're going to have a look at a exercise in the Java loops chapter, and the name of this exercise is PrimeDirective. And it says finding prime numbers is a common technical challenge in programming interviews. As it happens, Java loops are a great tool to help you do this. A prime number is an integer greater than 1 that is only divisible by 1 in itself. So let's also put this somewhere in our class as a comment, just to make sure that we remember what a prime number is. So a prime number is an integer greater than 1 that is only divisible by 1 in itself. So for example, 2, 3, 5, and 7 are all prime numbers, but 4, 6, 8, and 9 are not. Your prime directive is to build a PrimeDirective.java program that creates an array of all prime numbers in a given array. Okay. We've seen, if we have a look at the instructions, we've seen this one before. In the tasks, we have to check them off as soon as we complete them. So we read the instructions, we write the code, and then we go through all 15 tasks in order to complete this exercise. Okay, so if we have a look at the PrimeDirective.java, this is our file. And inside here, we had this class called PrimeDirective. Now it says, take a look at PrimeDirective.java. There's a class called PrimeDirective where you'll be creating your program. Inside the main, an instance of PrimeDirective. So we have this class called PrimeDirective, and then if we scroll all the way down to the main on line 36, it says inside the main, an instance of PrimeDirective of PD has been instantiated. Okay, so we have a variable of type PrimeDirective, so of the type of our class, and we create a new object of this, okay, by using the new PrimeDirective and then the parentheses on line 38. Below that, you will see an int array called numbers that has some numbers, some integers stored inside. So on line 39, we have a variable that stores an array of integers. Okay, so it stores quite a few numbers in here, and these are the elements, okay, the elements of the array. Okay, now it says to do import Arraylist from Java Util at the very top of our program, because we will have to, in this exercise, we will have to use and work with Arraylists. If you remember from the previous lessons, we have to import Arraylists before we actually are able to use them. So at the very top of the program here on line 2, we say import, so this is the keyword, and we type in java.util.arraylist, okay, and we end this statement with a semicolon. Okay, now we have access to all the functionality that Arraylists come with. We can take this task off because we've completed it. And by the way, if we ever get stuck, I'm definitely going to make sure that we use the hint here. So it says here in this yellow bar, it says stuck, get a hint. So we can just simply click on this and we get some hints about the program, about the code that we need to write in case we forgot how it's done. So at this point, at the very top of the file here, we imported our array lists. Okay, task number 2 says Optimus Prime. First, we need a way to determine whether a number is prime or it isn't prime. For this, we need to create an empty public method isPrime that has one parameter of type int, and the name of the parameter is number. And I've done this here on line 11. So we have a method called isPrime, yeah, just the way it tells us here. And our method needs to take one parameter of type int called number, one parameter of type int called number. Okay, so this is what our method takes. And this method will return true if the number is prime, and it will return false if the number is not prime. As soon as we see that the method needs to return something, we have a look at what is the type of the result that it needs to return. So in our case, true or false. The type of these two values are going to be Boolean. So therefore, we have to add them here. So we say public Boolean is prime, and in parentheses we put the type of the parameter that this method takes. I'm going to explain to you in a second what static means as well. Okay, but let's look at this for now. Okay, so we've done this. We said public Boolean is prime, and it takes an integer called number. Okay, so far so good. Now, if we have a look also at this yellow bar, at the hint, it says a method that returns true and false should have a Boolean return type. So of course we've done Boolean here. And somehow we know that at one point we need to also make sure that this method returns a Boolean value, okay? And depending on how we want to implement our code is going to be either true or false. Okay, so far so good. Okay, we can take this one off. And then it says take a moment to consider what a prime number is. Okay, so it must be greater than 1. So the number that we're checking must be greater than 1. And just by looking at this, automatically we know, or we should understand, the fact that we have to check using an if statement, okay, so a conditional block, to check is this number greater than 1. And only divisible by 1 in itself. Divisible, of course, means, you know, to check also for this condition as well. So if it's divisible by 1 and itself, okay. Now it says, in fact, every number is divisible by 1, so we don't really care about being able to divide by 1. Now, I think this, what follows here, made our job fairly easy, because otherwise we would have had to go and search online and see how we can actually implement this if we were to not have already the hint here. So it says, imagine we have a number n. If n is prime, then this number n should not be divisible by any integers between 2 and n minus 1. Okay. But how can we check this? Okay, so the way we can check this is we have a look here in the hint, okay, because otherwise it's going to be a bit too tricky. And it says inside prime, we have to create a for loop, okay? But where do we create this for loop? Well, the for loop needs to come. The for loop needs to come inside of this if block, because we have to check first if the number is greater than 1, like we saw above, okay? We need to see if the number is greater than 1, because if we know that the number is not greater than 1, then there's no point of going through check anything, or the program should not, through the logic that we're going to implement, the program will not check. I mean, it determines here, is this number greater than 1? If it's not, it's going to go automatically to our else, and then it's going to return false. Okay, so that's why we have to also implement this, because we need to understand, okay, what happens if the number is indeed greater than 1. Okay, so if it is greater than 1, then that's here where we can check if the number is actually prime, okay? And luckily, like I said, we've been given like this information here, which helps us to implement this code here in the for loop, which this is the code that is going to determine whether the actual number that we're given is prime or not. Okay, so it says inside the prime, we have to create a for loop, of course, after we've checked if the number is greater than 1. And we have to, if you remember, we have to use this keyword called for, okay? And then for the for loop, we have to, if you remember from the previous exercises and quizzes, we would treat this as 3 boxes. So this would be box number 1, this would be box number 2, and this is box number 3. So in box number 1, we would initialize our counter. In box number 2, we would put a condition, which in our case it would be I smaller than number. And then in the third box, we would increment I. And here actually it tells us inside prime, okay, so inside prime, after we check if the number is greater than 1, we have to use a for loop, and we set a counter equal to 2, which comes from here, okay. And we have to run the loop while I is less than the number itself. So I is less than the number, and then we have to increment I here, okay, which we do here at the very end of this line in the third box, okay. Now, what do we need to do here? Well, inside of this for loop, so essentially we're going through all the values that go from 2 all the way to n minus 1, okay? In our case being number, okay? Number minus 1. And we say for each of these values within our limits, so from 2 all the way to n minus 1, check if our number, okay, so the number given, modulo I, if you remember modulo, this operation is going to give us the remainder that is left after division. So say if we have 6 modulo 2, the result of that operation will be 0, because modulo checks if there's a remainder after the division. Would we have 5 divided by 5 modulo 2, we will have a remainder of 1, okay, because 5 does not divide by 2 straight away, so we would have some sort of a remainder, okay. So if the number modulo I, okay, so I is gonna take in turn all these values that are within this interval, 2 and n minus 1, from 2 all the way to n minus 1. And if the remainder of number modulo I is 0, then we have to return false, because it says here that if n is prime, then it should not be divisible by any integer. It means not to have 0 as a result of the modulo operation, okay. So if it has 0, then it's not. If it has 1 here, because obviously this result here can only be a 0 or a 1. So a number can divide by another number straight away, as in no remainder, or with a remainder of 1, okay. So those are the only two values that can come out of a modulo operation. So if our number modulo I is 0, then we have to return false, okay? And once it hits this, or any really, once our program, our logic that we implement hits a return statement, whether it's going to be true or false, it's going to break out of wherever it was there, okay? Okay, so we were here, increment by I. We can check this one off. We've done 3 already. We can check 4 off as well. And then if we have a look at number 5, it says, as you loop through each value of I, you want to check if the number is divisible by it. Inside the loop, check if the number is divisible by I. If it is, then the number is not prime, so you can return a false from the method, okay? So this is exactly what we've done here. We have to check if the number is prime or not, okay? By checking whether it's divisible by I. So we can take this one off as well. If we also have a look at the hint here, it tells us that actually we can use the modulo operation, just like this, okay? So modulo. Okay, if we have a look at that task number 6, it says below the for loop, we have to return true because number isn't divisible by any two smaller integers. Of course, we have to, so this, for example, this result here, return true, on line number 18, would come as a result of this checking, okay? So check if number is greater than 1, then return true. But of course, inside our if, if this is true, we still need to go and check this one, okay? But let's imagine that this one is not here. If number is greater than 1, return true. Else, so if is not greater than 1, return false, okay? This was that. And this, so this, the explanation that I just gave you ticks off the task number 6 and task number 7. Then if we have a look at task number 8, it says to test our isPrime method on PD in main, okay, to see if it works. So for example, what I've done here, I've tested it exactly with these numbers, okay, so with 7, with 28, with 2, and with 0, just to make sure that, since we already have the result given here, to make sure that we are indeed getting those results, okay. So now what I've done, I've gone to, if we have a look at line number 41 all the way to 44, I've run our method that we just created here. So let's check if whatever number we run this method with, if that number is prime or not. So I've run it with 7. Okay, let's comment this out for now. So I've run it with 7 and we should get a true, and then with 28 we should get a false, and then with 2 we should get a true, with 0 we should get a false. Okay, I'm gonna save this, and since we've done some changes to our program here, we have to first compile it and then run it. And the way we do this, if you remember, we have to use the Java C and then the name of our file, which is PrimeDirective.java. Okay, so I'm gonna press enter. And now this Java C, so the Java compiler, has created another file called PrimeDirective.class. So if I'm gonna do ls, so to list all the files that exist right now, so before running this command here, we only had PrimeDirective.java. Now after I've run the Java C, so the Java compiler, now this compiler has created PrimeDirective.class, and this is the actual file that we're gonna run. Okay, so Java, now if we say Java PrimeDirective, just like that, without, we can run it just like this without adding any extension at the end, so no dot class or Java or anything like that. If I press enter, we're getting the results printed on the screen, because obviously I've used the system.out.print because we know that this method actually only returns a Boolean value, but nowhere in our method is a print statement, okay? So it would not display anything on the screen, but knowing this, I've used the system.out.println to print us on the screen whatever values we get from running the isPrime method on different values, okay? So for number 7, we got true, which is true, and confirms that our code is so far so good. On 28, it should return false. On 2, it should return true. And then on 0, it should return false. So our messages that we see here on the screen, so the output that we see on the screen, is the same, is identical to what we should get here. Therefore, our code so far so good is good. So the implementation of isPrime, of the method called isPrime, is okay. All right. Okay, so we can tick off this task as well. Now, of course, it tells us this, which I don't need to do because we've already tested it with quite a few values. Okay. All right, now it says that all we have to do is to build an array list of prime numbers in the numbers array. So we have in our main method, we have this, this is an array list, we've seen it before quite a few times. Okay, so this is an array called numbers, or a variable called numbers that stores an array of ints, and these are the elements. Okay, now we need to create a method called onlyPrimes that is going to take as parameter an array, okay, an array of ints, actually, to be more specific, which is this one here. So we have to create a method called onlyPrimes that takes as parameter an array list of numbers, okay, which, to make sure that we keep it the same, yeah, we can do it like this. So our method takes as input a variable, whatever name it might have, so numbers can be called anything here, okay, but we know it's gonna be an array of integers. Okay, so this is what our method is gonna take, and this method needs to return an array list of integers. Okay, so here in the instructions it says you can create another method to handle this, because we want some sort of a like I explained before, we want a method that takes an integer called numbers, an array of ints called numbers, and from this list our method is only going to choose the ones that are primes and is going to put them in an array list of integers. Okay, so our method needs to return an array list of integers, which is exactly this piece of code here, and has a parameter numbers, which is an array list of ints, is this one here. Okay, we've done number 9, and then it says inside the onlyPrimes body, create a new empty array list called primes to store all the prime numbers that are found. So of course, in order to store all the numbers all the numbers that are primes from this array, okay, we have to create a new array in which we're going to store those numbers that are primes. Okay, so we say array list of integer primes, so this is the name of our variable, or of our variable that is going to store this object. Okay, and we say new array list of integer, and then we use the parentheses. We've seen this one where in the lesson where we talked about array lists. And now, in order to go through all the values, all the elements in our array list, again, this was covered in the array chapter, in the arrays chapter. So in order to go through all the elements stored in our array here, which is given as a parameter to our method here, we have to use a for loop. So we use a for loop for int I in numbers. So for each element of type integers in our numbers, which is an array, the array that stores all the elements, we can check if the number is prime. Yeah, and then if that number is prime, we say primes. So in this new array list, we're using the method add, which again we've seen in the array list lesson, add I. Okay, but where is this is prime method coming from? Well, we just declared it, we created it up here on line 11 in the previous steps, so before this. Okay, so it was very helpful to create this method that determines whether the number is prime or not, and then we make use of that method to determine whether certain values in an array of integers are primes, and if they are primes, then add them to an array list of integers. Okay, and we can do this very easily with the help of our variable, so the variable that stores our array list of integers, and then we use the method .add. Okay, and in parentheses we put the element that we want to add. Which element is going to be? Well, of course it's going to be the one that is prime. Okay, so if is prime of I is true, so if is prime, then add that element to our array list, okay? So wherever we need to store them, the ones that are only primes. Okay, we've done this one. Setup, okay, we've done this one as well. Now, if the number is prime, you can add it to primes. We've done it here, this one. And then at the end of the method, below the for each loop, return primes from only primes. So of course we need to return the from this method. It's clear from this line here, from this fragment of code, that we have to return something from this method, which is an array list of integers. And we've just created it here. We've populated this primes array list, okay? And now we say, okay, return primes. We can take this one off as well. And on task number 14, it says time to put it all together. In main, we have to test out the PD being our object here, okay, of our class, on the numbers array, okay? So we have this numbers array, and now I can uncomment this line of code, and we say on PD, okay, check my, so on our object, access the only primes method and pass it as an argument or as a parameter, pass it our numbers array, which is here, okay? And by running this, so I can now comment this one, these lines. And we will see what we get here, okay? So now we have to save it again because we've done some changes to this file. We have to use again Java C. So we have to use again Java C PrimeDirective.java. Okay, and then we run Java PrimeDirective. Okay, and now we're getting, this is the result of running our only primes method on the object we just created from this class, and we're passing it as a parameter this array of integers. And I've checked online to see whether these numbers are indeed primes. So is 6 prime? No, it's not. Therefore, don't add it to our primes. Okay. Is 29 prime? Yes, it is. So you can also check yourself to see that indeed all these numbers out of all of these are primes indeed. So therefore our code is correct. We can also now tick off this and tick off this as well because we have tested our code and it works. Now, I've said to you at one point that I want to also explain why I've made this method static. Well, a method is going to be static, or we declare it as static, if we want to be able to use it without actually creating an instance of this class. Okay, so here we could run actually this isPrime method only because it was declared as static. Had we not created it as static or declared it as static, we would have had to create an object of this class in order to be able to access this method. Okay, because we know that once we create an object from a class, we can't just create an object out of thin air. We have to have a class from which we create an object, and on that object we can call methods by using the dot notation. So what methods can we access? Well, we can access the methods declared inside our class, which is the case with the only primes method here, we haven't declared it as a static method. Therefore, we can use it on this object that is an object of type PrimeDirective, okay? Which is an object of our class. And since prime only primes was a method declared within our PrimeDirective class, then of course that each object that we create from our class is going to have access to the methods that are created inside our class, okay? But now, here, for example, on line 41, we were able to access and to use this method, to call this method without calling it on any object. And that is only possible because we have declared this method as a static method. So just to understand, the static method belongs to the class, okay? And it can be accessed without creating an instance of the class in order to have access to the method.